Look at this next function. It does again tell us that the quadratic parent is f of x, we know, is the same thing as y, right? Y equals x squared. And so we know again some other things, that if it's the same as y equals x squared, we know because it's squared, it's a parabolic shape, y equals x squared. So we know that it's 1x squared if you want to put the 1 in front. And we know f of x is the same thing as y. Okay, so when we look at this and we see a is 1, we know that we're not going to say it's narrower or wider than the parent. We know that when there's just y equals ax squared, a is 1 if you don't see a number before x squared. So this is some number, right? And if there's no bx, so just something x, and c is a number by itself, right? So if we don't see number x and the c, then we know our vertex is going to be 0, 0. Okay? The axis of symmetry then is the line that splits our graph in half, and it's the x coordinate of our vertex. So we know that the axis of symmetry would be x equals 0. The parabola, we know, has to open upwards because if a is 1, a is 1, and a is positive, and positive opens up. Again, we're not going to say narrower or wider because we're always comparing to 1. And the absolute value of 1 is not larger, so it's not narrower, and it's not smaller, so it's not wider. Again, though narrow, wider is opposite of intuition. So when you see this over here, this is just saying in the center that this y equals x squared is our equation that we're looking at. That's the parent function, right? Equation. And xy is an ordered pair. This is what we're going to have as the point once we plug in our x value, and this is what will come out, right? It's going to be some kind of point. And to plot a point, you need an x coordinate and a y coordinate. So it's going to be a point that we can graph. Now over here in this x column, notice that they plugged in random numbers. You always want to, and they plugged in specific values. If our vertex is 0, 0, you always, just like the absolute value graphs that we looked at before, you want to have your vertex in there. So 0, 0 is the vertex. And then you want to have ordered pairs on either side. So what happens is when they plugged in -1, their output was 1. When they plug -1 into x squared, right? For example, if you plug in -1 into the x slot, you would get parentheses when you insert -1 squared, which is -1, right? Times -1, which is 1. So that's why in went -1 for x, out came 1, right? And function notation, we would write it as this: f of -1, same thing, parentheses, -1 squared, which equals 1. And we use function notation to see what goes in and what comes out. So in for x, and this is what came out. Our y value of the ordered pair. That's why we use function notation to show somebody what goes in and out. So notice we plug in two x values on either side of the vertex, and the x coordinate is 0, so we pick two x values that are smaller than 0 to the left, -1, -2. You can pick any, and we pick two that are on the right. Notice, just like your absolute value graph, if you pick points that are equidistant from the center, so -1 is 1 unit, 1 is 1 unit, If you pick values that are equidistant, their y's are going to be the same. If you pick -2, that's 2 units to the left of our vertex x, we get 4. If we pick +2, 2 units to the right, we still get the same value, 4. Now just be careful if your center is not 0, okay? It's always the amount of units away from your center. Okay, now let's look here at example 2. If we look at example 2, understanding the graph of y equals ax squared in general, how does the sign affect the graph? So graph the 2 and look at the opposite. So this is kind of what we've been talking about, right? Make this a little bit bigger. So if we look at the top one, y equals 1x squared, we know that because a is positive, right, a is 1, we know that our graph is going to open up. Because the absolute value of a, which would be the absolute value of 1, which is 1, because it's 1, and we're always comparing the absolute value of a to 1, it's not greater or smaller than 1, so we wouldn't say it's narrower or wider than the parent function. So it has the same width, not narrower or wider, because the a value is 1, just like our parent. Like a equals 1, it's hard to draw on here, like the parent function. So a value of 1, if it's the same as the parent function, they're the same with, let's write PF for parent function. Okay, then if we look at the second one, we have f of x or y equals -1x squared. So again, if we look at the a value for this, since the a value for this one, since a is negative, that's why this parabola opens downwards, right? Positive is up, negative is down, and same thing. Because, so this narrower width thing is the same. Because the absolute value of a, which the absolute value of -1 is 1, it's the same as the parent function, so it's not going to be narrower or wider. Now, don't look at it and say, oh, -1 is smaller. No, that's why we say the absolute value, okay? Now let's look at some of these and let's try to graph. How does the value of a affect the graph compared to the parent? So again, we're going to say that the parent function, right, is y equals 1x squared. For these problems, we're not adding bx or c, okay, something x and a number, because we're just looking at this a value, which is the value in front of x squared, and we know it's a parabola because of the squared quadratic. So parent, we're comparing to a value of 1. So when we look at this first one, we see that the a value, right, is -0.4. For the second one, the a value is -5. For the next one, for the third one, it's 4. For the next one, it's 0.8. Those are all the a values. So for the first one, if we see that the a value is -0.4, we know two things. We know that our graph, since it's negative, is going to go upside down. We know for the next one, since it's negative, the graph is also going to go upside down. We know for the next one, because a is positive, it's going to open up. And then we know for the next one that our graph is going to open up. Remember, a of x, f of x, g of x, they're all the same thing as y, right? It's just giving it essentially a different name so that when somebody says, how does k of x compare? How does g of x compare? How does j of x compare? how does h of x compare? You know which equation somebody's talking about. Now, the a value could do two things. You have to see if it opens up or down, and would it be narrower or wider than the parent. So if we say negative 0.4, the absolute value. Okay, well, if we look at this, the absolute value is 0.4. And when it's less than 1, right, it's opposite of intuition. It's going to be wider than the parent function. If we look at this next one, if we take the absolute value of -5, since that's going to be 5, since 5 is larger, it's opposite of intuition. So since 5 is greater than 1, it's opposite of intuition. It's actually going to be narrower than the parent function. Okay, if we come down to this next one, the absolute value of 4 is 4. And since 4 is greater than 1, because we're comparing the a value of the parent function, it's opposite of intuition. So bigger would actually be narrower than the parent. And then if we look at this last one, it's an a value of 0.8. The absolute value is 0.8. And 0.8, since that's smaller than 1, the a value of the parent, we know that it's actually going to be wider than the parent. Okay, I'm going to stop there for a sec, and then you're going to watch the next video to see the graphing and the last problem.